Hi everyone, welcome to the AGU GeoHealth quarterly webinar series. So today's webinar is a OSPA winner showcase. We have two wonderful speakers, Libby Kolik from UC Berkeley and Halima Salaha. Sorry, please correct me if I pronounce your name wrong. From Wayne State. Um, they are the OPSA award winners in the last year's AGU annual conference. So we invite them to give us our showcase for their research presented in the conference. And since there are a lot of attendees today are students or new investigator, so we will also ask several questions for their instructions of how to present award-winning presentation at AGU. So before I uh, give the screen to them, I wanted to talk a little bit about this award. So you may be curious about what is OSPA award. So it stands for Outstanding Student Presentation Award. So it gives award to good presentation at AGU annual conference. It could be oral presentation, or poster presentation. Only students are eligible to compete. If you want to compete this year's conference, make sure you check the question asking in if you want to asking about the OSPA award when you submit an abstract. So once you sign up, you will be added to the list of competitors of this OSPA award, and you will be assigned by up to 3 judges during the annual conference. And those judges they will stop by your presentation at the time you present your work. They're probably gonna ask questions you need to answer, and some judges may post some questions after the presentation, then you are expected to answer as well. So the judges will evaluate your overall performance of the presentation. Then the award will give to the presenters that's the with the top ranked performance. So OSPA is a AGU-wide award. So each year, our GeoHealth session get 4 to 5 winner spots. So if you are interested in more details about this award, you can there's a website that you can check the details on the website. Okay, so I stop here. Then I will give the screen to Libby to present her research. Uh, so Libby, yeah, can you share your?
Yep. All right. Can everyone see this okay?
Yes.
Okay, wonderful. Um, all right, then I guess I'll introduce myself and get started. So my name is Libby Kulik. I'm a PhD student at the University of California, Berkeley in environmental engineering. And today I'm going to be presenting my work, which is called For Exposure to PM 2.5 from California's On-Road Mobile Sources, Relative Disparities by Race Ethnicity Remain Even After Decades of Emissions Controls. And this work is in direct collaboration with a wonderful team of co-authors from the University of Washington, as well as the California Office of Environmental Health Hazard Assessment. And a preprint is available if you're curious for more information down here at the corner. So I want to start with just a little bit of a policy background for this study. So oftentimes in environmental policymaking, we talk about co-benefits in terms of this two-dimensional axis of health impacts. And here I'm talking about air pollution health impacts, as well as climate mitigation benefits. So you might think, for example, that tailpipe controls, like adding filters to the back of trucks, really have beneficial for health, but less beneficial for climate. Something like a plant-based diet is beneficial for climate, a little less beneficial for health. And then policies like vehicle electrification and renewable electricity are somewhere in the middle with benefits on both axes. But recently, there's also been a lot of discussion about this third benefit axis of equity benefits. And so that's sort of the underlying question of today's talk is how do we craft an environmental policy that is this triple win for climate, health, and equity goals? And so there have been a number of studies in the recent literature that have looked at this type of question. For example, this paper from Picciano et al. Last summer in 2023 looked at two different looked at two different climate policies out in the future and modeled the air pollution health and exposure equity outcomes of these policies. And what they find is that while it was really great for health and really great for climate, it failed on the axis of equity. And so we're still left with this question of how do we achieve all three of these goals? So there's a little bit of a philosophical debate in the literature right now about this idea of sector-based policies versus location-based policies. So on one hand, an optimization modeling paper by Wong et al. In 2022 showed that sector-based policy was not an efficient method to reduce exposure disparity as opposed to location-based policy, which targets specific overburdened locations instead of high-emitting sectors. On the other hand, we know that a lot of economic sectors disproportionately expose people of color, and certain of these sectors have even higher exposures than others. And in fact, the transportation sector is one where there might be really high disparity mitigation potential, as was shown in Polonic et al. 2023. And so where this work fits into this debate is that we're interested in looking back at a historical sector-based control to sort of add to this ongoing debate in the literature. And so this work is grounded in California, which is where I am. But also we picked California because California has been a global leader in mobile source emissions controls dating all the way back to the mid-1900s when on-road vehicles were causing really, really horrible smog problems. But even in more recent times, and here I'm focusing in on the 2-decade period between 2000 and 2019, emissions of PM 2.5 and 3 precursor species have decreased pretty substantially in that period of time. And those reductions have come from reductions across the entire fleet, whether it's light duty vehicles, medium duty, or heavy duty vehicles. And so the main driving question of this study is that given that we know that exposures are disproportionately burdening people of color in California before this policy, has this policy led to something that is more equitable or less equitable? So to do this, we developed a novel modeling pipeline to estimate exposure disparities from on-road mobile sources. So we use emissions of on-road mobile sources from the state regulatory model called MFAC, and we have those emissions broken out by a diverse set of vehicle fleets. We run it through a novel pipeline that was developed by our team called Echo Air that takes those emissions and converts them into PM 2.5 concentrations using the in-map source receptor matrix. And then finally, we take those concentration fields, we estimate exposures, and we're able to assess disparity across race and ethnicity. So what did we find? The first thing that we found is that population-weighted mean exposure to PM 2.5 went down for everybody in the state of California across this time. And two major conclusions jump out on this plot here. The first one is that for every group and for the statewide average population, which is shown here in this black dashed line, exposure concentrations went down by roughly 65% on average, which is really good. That's a really effective and powerful policy from a health standpoint. But the second observation that jumps out here is that the relative ordering of groups in this plot is really static over time, with Hispanic Californians being the most overexposed group in every single year of the study. And this jumps out even more strongly when we look at the relative disparity in exposure to PM 2.5, which is kind of a percent difference between the exposure to each individual group and the statewide average. What we find here is that if this policy was really beneficial in terms of equity, all of these lines here would sort of converge around that zero as it goes forward in time. But on the contrary, these lines are really flat, showing that these disparities have persisted over time. And so that's the result at the statewide mean, but it's also really important when we talk about environmental equity to think about what's happening at the extremes of the distribution. So for this next result, we took all of the concentrations across California in every year. We sorted them in terms of rank, and then we binned them into deciles, and we looked at who lives in each decile of the exposure distribution. And when we look at the lowest 10th percentile and the highest 10th percentile, and we compare it to the demographics of the entire state, we find is that Hispanic Californians are disproportionately living in the highest exposure decile, while white Californians are disproportionately living in the lowest or cleanest decile of concentrations. And what I really want to emphasize in this plot here is that while they just look like really wide bar plots, these are actually stacked time series, really driving home the idea that these are really, really flat trends and they're not changing across the period of study. And so another way we wanted to look at these results was in terms of which fleets are contributing and how are those contributions changing over time. And so here for the next couple slides, I'm going to really focus in on Hispanic Californians because they're the most overburdened group in our study. And so when we look at the absolute disparity by vehicle fleet, which is the group's exposure minus the statewide exposure, and then we chop that into the fleets that are contributing. And then we're going to normalize that also by the total absolute disparity to look at the fractional contribution by vehicle fleet over time. Light duty vehicles emerge as the most responsible for these exposures, with the contribution to disparity spanning between 60 to 70% across time. The next most important fleet type is heavy duty vehicles, which are contributing between 16 to 24% of the exposure. But another way to think about this is not just who's contributing the most in aggregate to exposure, but which fleets are most disproportionately exposing groups. And so we do that by comparing the relative disparity by fleet by group. And what we see there is that for Hispanic Californians, they're the most disparately exposed to emissions from heavy duty vehicles across time, and that trend is also relatively static. There's a bit of an increasing contribution or disparity from light duty vehicles, but for the most part, these lines are relatively flat. So that was our result in terms of patterns across time, but it's also really important to think about patterns across space. So we take that same analysis, and here we're zooming back out to the full statewide population, not just Hispanic Californians, and we set up a series of pie charts that are showing the contribution to exposure disparity in a couple different spatial ranges. So here we have the statewide, and then I'm going to zoom in on two regions and two communities that are shown here on our map of California. I'll start with the San Francisco Bay Area, which has an overburdened community called West Oakland, which is just in our neighborhood here at UC Berkeley. And then I'll also look at the Central Valley, which is this darker green sliver through the middle of California, and the Arvin-Lamont community, which is located at that dot over there. And I want you to focus in on this dark purple sliver that is the contribution from heavy duty vehicles. And what really jumps out is how much this pattern changes depending on where you're looking and the scale of that space. So for example, a policy that you might want to use in the San Francisco Bay Area generally might not be the perfect policy for a community like Arvin-Lamont. And in the paper, we repeat this analysis across all 19 of California's overburdened communities. And we really emphasize just how heterogeneous this is in space. So I want to just close on a couple insights for future policy. So the first one is that spatial disparities in exposure are going to persist unless we alter where emissions are occurring. Exposure disparity cannot be remedied with reductions in system-wide emissions alone. And so if we want to achieve this triple win, it's really important that policy actions for exposure equity prioritize and target overburdened communities instead of just doing these blanket reductions on the same network of highways and roadways. So if you want to learn more, I put the preprint QR code up one more time, and feel free to send me an email. But thank you so much for this opportunity to share this with you again, and I look forward to questions.
Thank you. Any questions to Libby? We will have a chance to ask a question at the end of the presentation. Yeah, we're gonna do post-panel discussion and also QA session. Thank you so much. Yeah, that's wonderful. So our next speaker is Halima. She present our poster presentation and win the OSPA award. Today she'll have a more detailed introduction.
Oh.
Yeah, please.
Hi, can everyone see my screen?
Yes, it looks perfect. Yeah, looks perfect.
Okay, thank you. Hi, everyone. Good afternoon. My name is Halima Salah, and I'm a PhD student, PhD candidate at Wayne State University. And I'm happy to be presenting the presentation format of my AGU poster titled Comparing Global Emissions of SEDS CAMS version 5.1 and Eclipse version 6B and their effects on air quality and their impacts on air quality and human health assessments. This work is in collaboration with the work that I've done as a Ralph Cicerone Fellow at MCAR. I'd like to thank my supervisor, Dr. Yoshin Hong, and also Wenfu Tang and Simone Tilms at MCAR, and the rest of the Hong Lab group at Wayne State University. To start off, the motivation for this research project is that we're assuming that there already exists uncertainties in global anthropogenic emissions inventories for trace gases and aerosols in the three commonly used emissions inventories, which are SEDS, CAMS, and Eclipse version 6B. In the study that we compared the spatial and the annual total variability of NOx, SO2, CO, NH3, and the NMVOCs. In addition, we assume that that the uncertainties amongst the emissions inventories could lead to different impacts on air quality and human health. So if there are differences in the air quality impact of the three emissions inventories, then will this in turn affect human health impact assessments and estimates? So to start off with the methodology that we use, for step one, we looked through and analyzed the emissions inventories, SEDS, CAMS version 5.1 and Eclipse version 6B for the year 2015. The model, and we had step two was the model simulations. Using the Community Earth System model through NCAR, we looked using CAM6CAM, we looked at the 0.95 and 1.25 resolution for 2015. We had 4 cases, case 1 using SEDS, case 2 using CAMS, and case 3 using Eclipse version 6B. And lastly, for sensitivity, we also had a case that was run without any of the emissions inventories, where everything was turned off. The last step, where we looked at the human health impacts, we were quantifying the human health impacts due to PM2.5 and ozone exposures following Hong et al. 2021. So to start off, the intercomparisons of global annual total emissions. Firstly, we can compare the trace global emissions. We were able to intercompare the emissions inventories total of for 7 species. I have placed on the PowerPoint slides 4 of the 7 species that we looked into. As you can see on the left, like SEDS being in blue, CAMS in orange, and Eclipse in gray, we intercompared the global annual total emissions of for 2015, and we found that amongst for black carbon, for example, a 6% difference when compared to SEDS. We use SEDS as the baseline and intercompared. And we had found that CAMS, for example, when looking at the emissions inventory, it was archived as NO, and that we had to convert to NO2 in order to have a uniform comparison. And then we looking through the running the model, we were able to look at the spatial distributions of the annual mean surface PM2.5 mass concentrations. On the left, we have PM2.5. On the right, we have ozone mixing ratios of CAMS, the differences between CAMS and SEDS, and Eclipse and SEDS. The global anthropogenic emissions contributed significantly to PM2.5 mass concentration and ozone mixing ratios. However, we found that there existed substantial regional variabilities amongst the inventories. When comparing SEDS to CAMS and SEDS to Eclipse, for example, you can see the differences concentrated in different regions. And we thought that was very interesting, especially when it comes to the emissions inventories and looking at human health impacts. Now, when we get to the human health impacts, I would like to start with that when looking through when we look through at the different regions, there are 11 regions, and those are China, India, rest of Asia, Sub-Saharan Africa, NING, which is North Africa, Middle East, Latin America, Eastern Central Europe, USA, and rest of the world, and Canada. And we had found that the combined regional and that we had found that significant disparities, differences between the emissions inventories when looking at the premature deaths for the year 2015. I'd also like to preface that premature deaths are significantly influenced by PM2.5 due to the non-communicable diseases and lower respiratory infections. As well, for ozone, which are the chronic obstructive pulmonary disease, COPDs. This is at the tropospheric layer where human health that we have looked through studies and understood that impacts human health. As you can see, blue is for SEDS, orange for CAMS, and gray for ECLIPSE. We had intercompared and found that China and India had significant premature deaths for the year 2015. And we had also looked at the global annual premature deaths associated with PM2.5 and ozone exposure for the year 2015. And these are just the anthropogenic, due to anthropogenic activities. This, like I had mentioned in the earlier slide, in the first slide, where we had a case 4 that had none of the emissions for when running the model. This was used in order to clearly see where the anthropogenic emissions where anthropogenic activities, PM2.5 and ozone, had also were associated with PM2.5 and ozone exposure. And we found that for SEDS, the estimate being 2.9 million deaths for the year 2015, for CAMS being 3.3 million deaths per year, and lastly for ECLIPSE at 2.2 million deaths for the year 2015. So to conclude, because of the existing substantial discrepancies of regional and global annual total emissions for the trace gases and aerosols amongst SEDS, CAMS, and ECLIPSE in 2015, which led to differences in corresponding air quality impacts for PM2.5 and ozone, we found that the premature deaths attributed to PM2.5 and ozone exposure for SEDS and CAMS and ECLIPSE version 6B were 2.9, 3.3, 2.2 million respectively. And that was a clear understanding of how that the differences when it came to emissions and when looking at the surface concentration impact and how that was translated in the premature deaths. Regionally, we found that China, India, and rest of Asia were found to have the highest human health impacts associated with PM2.5 induced premature deaths. I'd like to acknowledge that the material based on this work was supported by the National Science Foundation. I'd also like to thank NCAR scientists and co-authors Simone Tilms and Wenfu Tang, who have provided immense support along with my advisor, Dr. Huang. I'd also like to thank Cheyenne, now defunct for those who run models, provided by NCAR's Computational Information Systems Laboratory, sponsored by the National Science Foundation. I would also lastly extend my gratitude to AGU for the 2023 Student Travel Grant and also for selecting this poster presentation for OSPA. And this is a poster that I had presented at AGU GeoHealth, and I had used the PowerPoint slides to clearly translate the poster to PowerPoint slides. But yeah, thank you very much.
Thank you. Any question to Halima? Okay. So now we are moving to the panel discussion stage. We have a couple questions about making presentations at AGU conference, and we want to discuss and get some instructions from the 2 winners. Okay, so first question to Libby. Is that your first time to present at AGU, or first time to present at a conference, any conference?
Yeah, this is my first AGU. I had presented at a much smaller conference in a lightning talk format, so I think this was my first, big audience, full-length talk.
Mm-hmm. And to Halima, is that your first time to present at a big conference?
This was my first time presenting in person. I had presented at AGU in 2022 when it was the virtual option, but this was my first time at AGU presenting in person.
Mm-hmm. How do you feel about presenting in person? Isn't that more nervous than the online doing virtual presentation? Like more stressful? I mean, sorry, it's a question still to Halima.
Oh,
Yeah,
okay. It's definitely outside of my comfort zone. I think that when it's virtual, you're in your own comfort zone, but the nerves part was easily avoided at AGU once you realize that everyone around you are your peers and also colleagues and people you would like to learn from. So I think that's the difference that I've noticed when it comes to virtual versus
mm-hmm,
in person.
mm-hmm. And is there any special tips or special strategy you use to overcome the nervous?
I think that staying grounded, um, I think that's sorry, how to overcome the sorry, I just saw your
Yeah. Oh yeah.
question in the
Yeah.
chat.
Yeah. Oh.
Oh, overcome the nervousness at the conferences. Um, I would say grounding yourself. That's helped me in practicing. But yeah, grounding myself.
Mm-hmm. Yeah. Thank you. And a question to Libby. So you mentioned that you did some pre practice or presentation in other conference events. And what is the special thing of presenting your work at AGU conference?
Yeah, I think one thing that's really special about AGU and especially the GeoHealth group is that it's so multidisciplinary and it's so big that, I think it was really interesting to see how many people were there from, well, first off, how many people were there, but also how many people were there from earth science, environmental engineering, policymakers, public health. I mean, you have to craft the story of your work to make it accessible to all of those people. And I thought that was a really cool, special thing.
And the next question is also to you. And so you did an oral presentation at last year's AGU, and you win the award. And how do you feel about how to effectively grab people's attention to your presentation? Any special strategies you use?
Yeah, I think I have a couple sort of big picture tips and ideas that are sort of in line with what I was just saying about how this is such a multidisciplinary group. So the first one is that, keep in mind that we do all the science to make these amazing papers, but paper figures are not always really good talk figures. And in fact, sometimes they're really bad talk figures. And so taking the extra time to think about that story that you're trying to tell and whether or not the way you're conveying that data or conveying that message is effective in an oral presentation, and taking the time to remake the figures if the answer is no. I also think a second one is that there's a delicate balance between making sure that your slides aren't too cluttered so that they're overwhelming and distracting, but also making sure that each slide tells a cohesive story. That if someone, takes a picture of your slide while you're presenting, that picture isn't missing some critical piece of information that is going to totally mislead whoever's looking at that picture later. So trying to come up with a way to sort of balance that in terms of space on your slide. And the last one, which is maybe a little controversial, but as you may have noticed, I'm a huge fan of animations, with the caveat that you need to make sure that you test those animations like 100,000 times so that nothing breaks during your talk. But being able to actually walk the listener through your slide step by step and what are the key ideas as you're saying them, if you can practice that and get that timing down, I think it's really helpful to keep the audience engaged.
Thank you so much. I like the slide on your presentation. Like you make the color of the other vehicles being gray, and just focus on the highway duty vehicles. Yeah, that's very helpful. Um,
Thank you.
so yeah. Next question to Halima. So you did a poster presentation in last year's AGU conference, and you win the award. What is your suggestions for making a good poster presentation? This could be either the like we want to hear everything about how to win a poster presentation.
Oh, sorry, I didn't catch the last part of your question.
I would just
Oh,
ask,
oh,
yeah, like what's
oh,
your suggestion of making a good poster presentation? Could be anything. Could you can talk about
uh,
poster design or your interaction with judges. Yeah.
yeah. I think that first and foremost, making it accessible in color, colors that are easy to read. When designing the poster, as Livy had said, like images, like figures, are not always translatable when it comes to publications or onto presenting to an audience. Choosing figures that are concise and explain what you're trying to tell the audience. Focusing on a story, guiding it, like physically guiding the poster in itself, making it more engaging when people come by, being very engaging to an audience and speaking to everyone that is even curious, answering questions afterwards. I think that like leaning into the curiosity and making things accessible in design and understanding, and also communicating the idea of why you were passionate about the topic and the subject in itself, and what made you do the like what motivated you to continue the research. I think that's the effect. That's my experience in the poster designing, and also the presentation as well.
Thank you. I saw you have a lot of graphs on your poster. So just want to ask a silly question. If we quantify the ratio of text versus graphs on a poster, what is the best ratio you think? Such as if we do the similar amount of text and the graph, then the ratio is 1 to 1. And what do you think is the best ratio? Should be more graph or more text? What's your suggestion?
So it really depends on the context of what you're trying to communicate. I understand some believe in 1 to 1 ratio. There's also a 2 to 3 ratio. So I am guided by what I'm trying to say. For example, in my methodology section, instead of just making into bullet points, I decided, why don't I guide it by creating a dialogue, like in moving from one step to another. For my other figures, I think that if I were to quantify it, probably to 40 to 60 ratio, or 2 to 3 ratio for text and graphics. And even if there are texts, trying to make it more interesting and not just limited to the traditional way of bullet points.
Thank you. So I think there's a question to Libby from audience. Um, how about let me we do the panel question first, then we're gonna do the QA with with the audience at the end. Yeah, thank you. You can for everybody here, if you have any questions, feel free to post it in the chat box, and we're gonna do a QA session at the end of this event. So next question, can both of you share any feedbacks you received from your last year's presentation? Both positive and negative comments are welcome.
Go first. In terms of positive comments, um, a couple of things that I got was that the slides were polished, that I kept to time, and there were a few more comments from the judges that really appreciated the sort of background and motivation and context setting. And then in terms of constructive comments, I think I got a few that were, that probably my presentation could have used a little bit more discussion of the methods or the limitations of the analytical approach. Which can be tricky when you're trying to squeeze everything into an 8-minute talk, but it's definitely something that I'll work on in the future.
Um, Sorry. For me, the comments that I had received, the constructive comments were um, significantly improved like how I discussed, especially for my plots for the regions, especially when it came to the Indo-Gangean plain. I had comments regarding that and how to explain why premature deaths were concentrated in certain regions than others. Um, Positive comments that I had received were the design and the colors that I had chosen. Um, yeah, so I definitely learned a lot in how to effectively communicate. And yeah, the feedback was generally very useful and very helpful for me.
And any special comments you think you can share here? I think it's interesting, helpful.
I'll note that the work that I presented on, we had just submitted for review at the time of AGU. And a few of the technical comments that I got ended up being very much in line with the peer review comments that we got. So it was actually kind of nice to preview this work, get a sense of, okay, these are the sorts of things people are asking about. So by the time peer review came around, I'm like, okay, my answers are really ready for this.
Thank you. Uh, anything to add, Halima? Yeah.
Yeah, similarly, a lot of the comments that I had received were then translated onto my paper, which is under review with some of the co-authors. But there was a lot of comments that I definitely learned a lot from, questions that I hadn't thought of, ideas, and also just the physical aspect of being at the conference allowed me to go to other poster presentations that were similar or in topic with mine, especially within the GeoHealth. And I learned a lot from just being there and being around other researchers.
Yes, going to conference, like getting comments from the other people is an important reason to go into conference. Yeah. So next question. Is there any like a common mistake you think people should avoid when they preparing or presenting their work at the AGU conference? And now it's a time to submit the abstract to this year's AGU conference, and also maybe start thinking about how to do the presentation. So can you give us some advice, like whether there's any mistakes we should avoid? Uh, yeah.
Yeah, I think the number one thing for me is really thinking about what is your session about, who is the audience that you're presenting to, and then how do you make that story compelling to those people in that crowd? I think trying to gauge, is this the methods development session? And I really need to get deep, deep, deep into the weeds about how this works exactly. Or is this more of a policy oriented or big picture session? And people are really interested in like the overarching story of how your work fits into this picture. I think I definitely went to some talks that, I was looking for A and got B, or went looking for B and got A, and that can make for you know, a less than ideal presentation. And then I also really want to emphasize the point I made earlier about figures from papers versus figures for talks. I think, a lot of people, just kind of grab those figures and put it on their slides, but it really does go the extra mile to do that figure change. Then the last thing is just, make sure you give yourself enough time and practice a million times. Don't wait until the last minute, I think is a very common mistake people make in academia for everything. So, make sure you give yourself enough time, draft things early, practice, practice, practice.
I also would like to say when it comes to the mistakes in presenting, also practicing, for my case, when speaking of premature deaths, being very sensitive about the topic in terms of like speaking from it in the sense of as a scientist who has like not reducing things to just numbers, but also doing the extra mile of understanding why there are the causes, understanding how you're communicating to a general audience. So not everybody is doing the same research and work. figuring out how to effectively communicate to an audience that might not know what your research is about. I also had realized once at being at AGU, there were a lot of comments as to which one is better. Being very careful in terms of like emissions inventories, being careful in the language being used when it comes to emission inventory comparisons. For example, I think that using your poster to speak for you and not having to add additional comments outside of the scope of the research that you have done. I think that was something that was really helpful for me. Um, I think that, yeah, focusing on the fact that there's 20,000 plus people who, many of whom are in your field, um, your peers, future colleagues, even friends, and future mentors as well. I think that looking at it from the perspective of being humble enough to learn for different fields, and I went to a lot of talks and definitely learned a lot more in different disciplines. Yeah, so that's uh, the preparation for AGU on my end.
Thank you. Thanks for both of you. That's very helpful. So next we're gonna move to the Q&A session with the general audience who are here today. So in the chat box, there's a question to Libby. Do you have ideas for a revised policy that could give a triple win, climate, health, equality? It's probably a scientific question to your research.
Sure, yeah, and that's a really good question. And really, one of the motivating questions of my dissertation work. So thank you for that. I think when we think about this triple win, if we really want to have that third axis of a benefit and we really want to prioritize equity and exposures, then the emissions reductions that we do that directly impact equity are also going to reduce those emissions for general air pollution, health, and climate. So just to give, I guess, a concrete example of that, right? If we took every vehicle across the state of California and we just reduced the emissions by converting a flat 15% of them to electric vehicles randomly and homogeneously across the state, then we would get that air pollution benefit, we would get that climate benefit, but we wouldn't necessarily get the equity benefit. But if we instead took all of those resources and we said, all right, let's target this one specific environmental justice overburdened community, and we give every single member of that community an electric vehicle, then, the same amount of emissions have gone down in terms of climate forcers and air pollutants, but we've also now given them the infrastructure to locally reduce those emissions, and that's going to have an equity impact. So that I think is, a very theoretical, hypothetical scenario, but you can think about that same idea that you could apply to different types of policies across the state. So for example, things like low emission zones or no trucking zones, or even just moving away from the transportation sector, if you target just a couple of top emitters of industrial emissions that are happening in these overburdened places, you can cut the emissions while also cutting the disparity in exposure. Thank you again for the question. It's a really good one.
Yeah, it's a just add some follow-up some additional thoughts because the heavy duty vehicles are there are a lot of heavy duty vehicles distributed in low income neighborhoods. So if you focusing on reducing emission, for example, change light duty vehicles to electric, it just doesn't help the equality. Sometimes maybe even increase the equity issues. Yeah. Any other questions? Any additional thoughts or advice from the two speakers? Are both of you gonna join this year's conference?
I
Yes,
can do a
I'll be there.
shameless plug. I'm chairing a session through GeoHealth that everyone on this call should apply to. So I will be there as well.
I'll also be there and I'll be co-chairing a session too. I'll see you there, Libby.
Looking forward to
Okay.
it.
Okay. I'm probably gonna be there too. I'm probably gonna be our judge of this year's OSPA award. So yeah, we see each other in the conference and see everyone in the conference. So any thoughts, comments, questions? Okay, so thanks you again for both of you for presenting this webinar. And also congratulations again for winning the OSPA award. I hope you will get the best for your research and also your daily life. Yeah, for the audience, if you have any questions, you want to reach out the two speakers, you feel free to send an email to AGU, GeoHealth, or send it to me. So we will forward your questions to the speakers. Thank you, everyone. Bye. Have a good day.
Thank you.
Thank you.